favorite canvas is the web. Billions have been invested into the web as a graphics engine, and it has become very fast. We have primitives for drawing videos, images, text, SVG, the HTML5 canvas element as well. And so we're going to use this as our canvas. Chapter 1, making our canvas. To do what I've just shown you, we would just render a React component, we would have a video tag, we would have an image tag, position it absolutely. Not very surprising to you, probably. But we need another dimension, and that dimension is time. Because with this, we have just rendered an image. However, a video is an image that changes over time. And this is where Remotion comes in. Remotion adds a time dimension to a React component. So this seems like a good spot to introduce myself. I am Jonny. I created Remotion. Over the past 3 years, we have been mainly pitching it as a way to make videos programmatically. And even last year, there was a talk which teach the basics of Remotion. So I didn't come here to do the same again. I came here to build on top of this, and this time we're not going to build a video, we're going to build an entire video editor. So this is the same component as before, but now we are using some Remotion tags. By using the off-thread video tag, we are synchronizing the video with the Remotion timeline. So if the Remotion's internal time is at 10 seconds, then this video is also at 10 seconds. But it is still regular React, which means we can pass in props and that way parameterize the video. We can also change the props and the video will update. This is how we are going to make our editor interactive. If we have this component, we can render it onto a web page using the Remotion player. It's another component which takes our Remotion component, allows to pass in some props, but also define some metadata like the width, height, frame rate, and duration of the video. It looks like this. So we have a video that is playing. Also, we have some controls that allow you to play, pause, jump to a different portion in the video. This will all just manipulate Remotion's internal time. But since we are going to build a video editor, this is not quite enough to have these default controls. Because if you are going to later drag and resize things around, then these controls are kind of in the way. So what I would recommend to you is to disable the default controls and instead use our brand new copy-pastable components. You can go to this page and, for example, copy a play pause button, put it anywhere on your page, and this should then look like this. Now the controls are outside of the player, and our canvas is unobstructed. Chapter 2, adding content. Let's first start by defining the data structure of our items. In our canvas, we can have multiple types of items. For example, we can have videos, we can have images, we can have text. And maybe some of these items have a common ground, like a position, the starting position, and the duration. So here I created a base item TypeScript type. And for the specifics of each item type, like for example, an image has a source or a text has a text, I have created the types like this, and at the end we create a discriminated TypeScript union so that we can easily distinguish between different item types, but still treat it all together as just an item type. To render an item, we would create a component like this. We have the positioning, But then if it's an image, we render an image tag. If it's a text, we just render a div. It's really just React. I feel like this should be nothing new to you. Let's define some tracks. In our video editor, we can put items on different tracks, and depending on which track you put it, it will change whether the item will appear on the top or at the back. And a track is just an array of items, essentially. To keep state of our tracks and our items, we just use a regular use state. I really wish this was more interesting, but it's just boring old use state, how you use React every day. And to render a track, we just loop over all of the items. And now when it comes to the question, in which order shall we render our tracks, a big problem you will face when building a video editor is like C-index issues. Which items should appear at the back, which items should appear at the front, not just for visually overlapping each other, but also then when it comes to mouse interaction, because the items which have a higher C-index, they take mouse events, while the ones at the back do not. So it's essential to know that when you have multiple absolutely positioned elements, the item that gets rendered last appears on the top. This does not just apply to Remotion, this is just like generally how CSS works. So if you know that, you don't need to use C-index at all. You can solve the problem just by rendering the items in the right order. Okay, we have rendered our tracks. Now let's accept some files. I'm wrapping the player in this component, which just, when a file is being dropped on it, handles it. And our handling function could look something like this. We check the MIME type of the file. Here, in this example, I have shown how a video would be handled. We first create a local blob URL, and we immediately add it to our state so that we can show a local version of the video in the video editor immediately while it is uploading to the cloud storage. I'm also using the getVideoMetadata function from Remotion here to obtain the width height, so that when you drop the video, it at first has the natural dimensions. And in my example, I've even made it so that when it's the first video being dropped, the whole canvas resizes to match your video. I find that quite nice. After we have made a local preview, we are also uploading the video to the cloud. This is not a local video editor. This is one that works in the cloud, so that you can also synchronize projects across computers. And also mostly because we are also rendering in the cloud. I think the best way to handle these file uploads is to use AWS S3 pre-signed URLs. How it works is that on your backend, you use your AWS credentials to generate a pre-signed URL, and you send that to the client. The benefit of that is that when you upload a file, it goes directly into the S3 storage and does not need to go over your server. But you're still able to put in some checks. So you can, for example, rate limit the endpoint so you don't give your users free file storage. Once we have obtained that pre-signed URL, we can, on the front end, upload the file. This is the pretty example using fetch. There's also a less pretty version of this, because if you want to upload a file and at the same time track the progress of it, then as of October 2024, you still need to use XML HTTP request. It's super sad. So probably in the actual code, you wouldn't use this. But this is the pretty version. And once we have uploaded the file to the cloud storage, we replace the local URL with the remote version. This is how it looks like. I have also added an upload progress state. And yeah, while I was recording this screen, the internet wasn't super fast. So that is a bit of a bottleneck. But we have implemented file uploads now. Chapter 3, editing content. In general, how do we manipulate an item? Its position, its size, or any other parameter? We update our state that we have defined using useState. And because we have a bit of a nested structure, I would recommend creating a helper function like this, like a change item function, so that you can easily update an item by its ID. In a video editor, items can also be selected. For example, by clicking on the item itself or by clicking on the layer in the timeline. And for this, we just use a regular useState. Items can have outlines drawn around them, either if they are hovered or selected. And for this, I have created this component, an outline component, which is also absolutely positioned at the same position as the item itself. I have implemented a hover state, and when you click with the finger or the mouse on it, we set this as the selected item. Now, the complicated part, how do you make a UA like this, that we have multiple items that can be resized. This is a bit too complicated for this talk. I only have 16 minutes left. So I'm going to leave you with this link. There I have written an extensive tutorial going into also the intricacies of how to implement such a thing. In which order should we render all of the things that we have right now? We have the items itself, which in my opinion should be rendered at the back. And then we have the outlines, which we render lower in the tree, so that they appear on top of the other items. And here I found that the only way it works correctly is that we render the currently selected item at the top. So depending on which item is selected, we change the order of the rendering. And this is because the currently selected item can be moved around and resized, and therefore it always needs to accept the pointer events. Now, in Figma, I have seen the following pattern, that the content itself does not overflow, because if you move an item to the side, it would also be cut off in the final video. But it would be nice to show the outline nonetheless. And I have achieved this also by separating the tracks and the outlines and applying an overflow hidden to our items. I've also made so that when you click on an item, things appear next to it. So on an image, you could change the source. On an audio, you could change the volume. And based on a selected item, I'm just rendering some controls, which just update the state. If you click on an empty space in your video editor, you want the items to be deselected. And at first, I had a very messy implementation, but I figured that the best way to do it is to just, whenever you want to handle an event, you call event.stopPropagation on it. So that in the end, at the canvas level, when you receive an event that has not been, whose propagation has not been stopped, you can say, okay, we are deselecting the item. All right. Now, we are also adding captions. Are you excited by this? Okay. Maybe now, captioning with AI. Yeah, that's right. We are using AI now. But first, we are extracting the audio from the video or from the audio as a wave using this code. For this, I found it easy to use this audio buffer to WAV library. We are uploading this buffer to our endpoint. And now, this is the AI slide. We are sending it to OpenAI Whisper using this snippet, using these parameters. To be honest, I'm not fully satisfied with this implementation because when you upload the file, it first gets buffered in the function. And only once it has been fully received, it gets forwarded to OpenAI. So it feels like it could be done better, but I didn't quite figure out. Let me know if you know how to. OpenAI gives you a transcript at the end. And we are doing some post-processing with the brand new Remotion captions package. The captions package essentially just exports a TypeScript type, which looks like this. And the idea behind it is that if all of our captions are structured with this type, assume this TypeScript shape, then we can write a set of helper functions that deal with captions. So we are converting our OpenAI response to this caption type, but we also have a way to convert, for example, the output of a local Whisper CPP to this shape. So we have multiple providers, and they can all assume this shape. But for this example, I have just used the Cloud OpenAI Captions API. Once we have received an array of captions in this shape, we are creating what I call pages using the Create TikTok Style Captions API. If you have seen a TikTok, you will see that they have captions around here, and sometimes there's just one word at a time, sometimes there are multiple words at a time. Using the combined tokens within milliseconds parameter, we can adjust how many words are displayed at once. If you set it to a low amount, then only one word will be shown at a time. If you set it higher, then it might be a bit more readable because the pages don't change so fast. Now that we have created caption pages, we are rendering them like this. Using the Remotion sequence component, we can make content only appear after a certain time and limit their duration. And that's how we render each page after each other. Another interesting problem, which font size should we give to our captions? The font should be as big as possible to fill out the entire width and height that we allow the captions to be. But it may also not be too big. If there's just the word hi displayed on the screen, then if we would use the maximum allowed space, then it would be really big. So we are also clamping it. So we are calling the fit text API. With this, you can find the right font size if you want to fit a text within a certain container. If there are multiple words displayed at the same time, it is also nice to highlight the currently spoken word in a different color. I'm sure you know what I'm talking about if you have ever seen a TikTok. And this we do with this code. Essentially just checking what the current time is, and if it's the currently spoken word, we highlight it in a different color. And finally, I've also implemented a caption editor. I'm also not going to go too much into it, how it works, but it is essentially just, we used useState for the captions, and for each caption we rendered an input. When you change the input, we update the state. We also use very regular React for this. Okay, let's see where we are right now. I've until now shown a lot of code, but very little demos. So we can upload a video if the Wi-Fi is good. And since we have the local version of the video, we can already extract the audio and generate the captions. OK, great. Seems like it uploaded. We can also resize. As you can see, the content clips here. Woo! And our captions have now been generated. That's great. We also have these controls here for centering content. We can even, I've just treated the captions as another box that has a position, and we can just edit the captions in any way we like. All right, great. I'm also going to show you how to upload an image. This also works. I even made a way to put some solid rectangles, if you like, and a way to put a text, even though this one still lacks a bit of development, since I have not implemented a way to change the font size. I've also implemented a timeline. I know I've not gone too much into how this one works, but essentially it's just a very elaborate way based on pointer down, pointer enter, pointer leave events to then update our state, our array of items. Finally, let's render the video. And for this, we are using Remotion Lambda. It is a renderer which renders a video on AWS Lambda serverless functions. It's also a distributed renderer, which means that once you invoke a function, it invokes more functions, which each render one chunk of a video and then at the end concatenate it together to produce our final output. Super cool technology, but not the scope of this video. So I'm not even going to explain how to set it up, but don't worry, you will manage. This is the part of Remotion that is very well documented. We also need to create this Remotion entry file and render a so-called composition. This again just registers the component. And here we have the ability to call a function that calculates the height, width, frame rate of the canvas, as well as the duration. And this is also an interesting question. What is the duration of our final video? For this, I have just implemented in this way that we loop over all of the items, and whichever item has the longest timestamp, that is the overall duration of the video. We are deploying a Remotion Lambda function as well as our code. This would look something like this. And we are creating a rendering endpoint. Here, I've just used Next.js, but the cool thing is you can pretty much implement this in any React framework. Using the render media on Lambda function, we can trigger a render, and using the getRenderProgress function, we can retrieve the overall progress of the render. So what we now have to do is to just call the render function once, and then maybe every 1 or 2 seconds or so the progress function, so that we can display a nice progress bar. This is a bit of front-end boilerplate code that is necessary. We have a render button, a progress bar. At the end, you get a URL that points to an item in S3. And if you visit that URL, the video will be downloaded. And of course, we should also handle the error. So, in practice, let's now hope this works. We have this render video button. And now let's see if our video gets... Actually, I should play you the video. I've not shown you the video. All right. The video has been rendered. Yeah, trust me, the video is going to look exactly how you expect it to be, an MP4 video. And therefore, I would say we have done it. We have created our own very simple video editor. And you can visit it here for now. I don't know yet exactly what I'm going to do with it. My plan isn't really to build out a full video editor. My plan is to, using experiments like this, figure out the weaknesses of Remotion and improve them, and overall teach you how you can build your own video editor. So during this process, I've also created like 6 or 7 new documentation pages to just hopefully do a lot of the heavy lifting that you would face when building a video editor. So I'm not hanging on too much to this project. So I'm giving the source code to all of you React India attendees. Just DM me, and I will be happy to give it to you. All right, I'm glad we made it in time. Then I have some time to do some plugs. If you want to see more content from me, then follow me on Twitter, and I also have a YouTube channel. Same goes for Remotion. On the Remotion channel, you can learn more about Remotion itself. And myself, I do some fun content. I make video essays. I talk about interesting problems, the daily work. And on our YouTube channel, we do completely wild content. Can you believe we recently went on Shark Tank with Remotion? So we went on Swiss television and presented them a programming framework. If you want to see how that turned out, then check out my YouTube channel. And yeah, thanks a lot for letting me be here. As Tej just mentioned, for me, this has a lot of personal value as well. Till a few days, I was never in Asia at all. It's my first time in India. Everybody has been super nice and generous, and it's absolutely overwhelming. I don't know how to give it back, and especially now that this opportunity has come up to speak here, and I'm now so close to Sri Lanka, where my father is from. I'm also going to visit it in the next few days. So a very special thing for me, and I will never forget being here. Thank you for making this possible.